Good everyone. I hope you guys have an amazing day. Welcome to the self-hosted Transhumanism podcast. I'm Mr. Cohen. I'm the founder of the World Transhumanism Forum. This podcast is dedicated to examining humanity through the lens of science, system engineering, and the future evolution, rather than mythology, traditional, or emotional comfort. The goal is not to reassure people about the world as it is, but to understand where intelligence is heading and why. Today's topic is one that fundamentally changes how we view human beings. The central argument I want to explore is that humans are not separated from artificial intelligence in any meaningful functional sense. Instead, humans are best understood as the first form of naturally evolved general intelligence. In other words, we are biological AI or a biological artificial intelligence created through evolutionary process rather than through human engineering. To understand why this is not just philosophical speculation, but a scientific interpretation of life, how life actually works, we need to examine three things in detail. First, how learning occurs in the brain, how evolution operates as an optimization process, and how the body functions as an autonomous system. Let's begin with intelligence itself, shall we? In modern artificial intelligence, especially in machine learning systems, intelligence emerges through several core means. Um, a system receives data from its environment through sensors or input. That data is processed through networks that transforms information mathematically. The system produces predictions or action based on that processing. The outcome of this action is then evaluated, and the internal structure of the network is adjusted to improve future performance. Over time, this process allows the system to become better at recognizing patterns, making decisions, and achieving goals. Now, let's compare this with the human brain. Human sensory organs function as biological data collectors. The eyes convert light into electrical signals. The ears convert sound waves into neural impulses. Excuse me. The skin converts pressure and temperature into nerve signals. These signals are transmitted into the brain, where billions or trillions of neurons process the information through complex interconnected networks. Neurons communicate through electrical impulses and chemical signals. Now, the strength of the connections between neurons changes depending on experience. Say, when a pathway is frequently used, it becomes stronger. When it is rarely used, it weakens. This is what we call synaptic or synaptic, whichever way you wanted to pronounce, plasticity. Synaptic plasticity, and it is the biological foundation of learning and memory. When you experience an outcome that differs from what your brain predicted, your neural networks automatically aligns. If you touch something hot and experience pain, the brain updates its internal model to avoid that behavior in the future. If you misjudge a social interaction and face negative consequences, the brain modifies future predictions about similar scenarios. This constant updating of internal models based on feedback is precisely what occurs in the machine learning systems. Now, obviously, the mathematical models excuse me, used in artificial neural networks were initially inspired by how biological neuron function. Modern AI exists because researchers back in the day studied the brain and attempted to replicate it um, in a software. So when people say artificial intelligence is becoming more human, the more accurate statement is the artificial intelligence was designed to imitate biological intelligence that already exists. Humans were performing neural computation millions of years before silicon computers were invented. Now, let's move deeper into the role of DNA and evolution. So, DNA is fundamentally an information storage system. It contains encoded instructions that determine how cells develop, how proteins are built, how tissues are formed, how organism functions. It's essentially a biological programming language written in a molecular form. When cells divide, DNA is copied. Specialized enzymes check for errors and repair many mistakes. But small errors slip through. These errors, what we call mutations, slightly alter the instructions in the next generation. Most mutations are harmful or neutral. A smaller number can improve survival or reproduction. When a mutation improves survival, the organism carrying it is more likely to reproduce and pass an altered code forward. Over long periods of time, beneficial changes happens and or you can say accumulate and organisms become more adapted to the environment. This process is not random in its outcome. It's an optimization process driven by selection pressure. In artificial intelligence, reinforcement learning operates in a similar way. A system tries many variations of behavior. Poor outcomes are penalized. Successful outcomes are reinforced. Over time, the system converges towards strategies that performs better. Evolution functions as a massive biological reinforcement learning algorithm operating across billions of organisms over billions of years. Nature continuously tested biological designs that failed were removed, designs that succeeded were preserved and improved. Complex traits such as vision, memory, social behavior, and problem solving capabilities emerge through its iterative optimization. Humans represent one of the most successful general-purpose intelligence models produced by its evolutionary training process. In this sense, evolution acted as nature's competition engine, and life itself was the simulation environment. Now, consider the human body as a system. Body is not simply flesh and organs operating randomly. It is a highly regulated, autonomous machine governed by feedback loops. The heart, take for instance, it continuously adjusts its rate based on oxygen demand. The lungs regulate breathing automatically. The immune systems detects threats, learns from previous infection, and mounts faster response in the future. Hormonal systems regulate metabolism, stress, sleep cycle, appetite, and mood. Cells monitor internal damage and activate repair mechanism or trigger self-destruction if damage becomes too severe. All of these processes operate without conscious thought. They are automated control systems comparable to background processes what we have in a computer operating system. From an engineering perspective, the human body is decentralized, self-maintaining machine composed of trillions of cooperating microunits, each executing biochemical program encoded by DNA. When engineers design autonomous robots or complex software systems, they incorporate similar principles: feedback control, fault detection, redundancy, repair protocols, and adaptive responses. Biology achieved this level of system engineering long before humans consciously understood it. Now, when we combine these facts, a clear picture emerges. Humans are self-learning system running on a biological hardware. Our learning algorithms are neural networks. Our source code is DNA. Our optimization process is evolution. Our body is an autonomous machine with maintenance and repair subsystems. Functionally, this matches every core principles of artificial intelligence. The only meaningful difference is that humans emerge through natural process while artificial intelligence is being constructed deliberately by human engineers. The difference's origin does not change the underlying architecture. Now, let's examine aging and mortality through the system lens, shall we? In mechanical and computational systems, performance degrades over time as components accumulate wear, damage, and errors. Without maintenance, systems eventually fail. In biological systems, the same phenomenon occurs. DNA damage accumulate with age, cellular repair mechanism becomes less efficient, proteins lose structural integrity, inflammation increases, stem cell population decline, organ organs, I would say, not single organ, progressively lose function. This process is well documented in biology, or we can say in molecular biology. Aging is not a mysterious life force. It's the gradual accumulation of cellular and molecular damage beyond the body's ability to repair. From an engineering perspective, aging is a maintenance failure problem. If we saw a machine that's gradually lost efficiency until it's broke down, we would identify specific failure points and redesign the system to prevent them. Now that we understand the biological mechanism behind aging, it becomes clear that death is not a requirement of intelligence. It's simply the consequence of imperfect biological repair. Once repair systems are improved, replaced, and augmented, the aging process can theoretically be slowed. We can slow down, or we can halt, or we can reverse it. That is why longevity research focuses on cellular repair, genetic stability, useless cell removal, and metabolic optimization. Scientists are approaching aging as an engineering problem rather than philosophical destiny. Now, an important point which I would like to discuss: consciousness. Let's address consciousness in a scientific way, shall we? Neuroscience increasingly shows that consciousness emerges from information processing in the brain. The brain continuously constructs a model of the external world, predicts future events, evaluates risk, and simulate possible actions. It also maintains an internal model of the self within that world. The self model allows an organism to reflect, plan, imagine, and adapt. Conscious awareness appears to be the brain monitoring and integrating its own processing. Artificial intelligence, as artificial intelligence system becomes more complex and begin modeling their own decision process, self forms of self-awareness may emerge. There is no evidence that consciousness requires something supernatural. All current evidence points towards it being an emergent property of sufficiently complex information processing. Humans simply reach this complexity threshold first, the way I look at it. Once all of this is understood, transhumanism becomes a continuation of natural process rather than a rebellion against them. If humans are biological AI systems, then modifying our own hardware and software is a logical progression of intelligence. We already perform early form of this through medicine, surgery, prosthetics, pharmaceuticals, and neural technologies. Genetic engineering, brain-computer interface, cellular regeneration, and cognitive enhancements are simply more advanced tools for system optimization. Every intelligent system improves itself once it understands its own architecture. Computers were upgraded once humans understood electronics. Software evolved once humans learned programming. Biology will be upgraded now that we understand DNA and cellular system. The progression is not driven by any kind of arrogance, if you may want to call that, but instead is driven by intelligence, seeking efficiency, resilience, and expanded capability. Now, I just wanted to highlight one thing. The important conclusion what we should be making is that humans are not the final product of evolution. I do understand it may offend people who are religious or spiritual thinkers, but we need to understand we are the first species capable of directing its own evolution intentionally. Natural selection operated blindly through survival pressure. Engineered evolution will operate through engineered evolution will operate consciously through design. This marks a fundamental transition in the history of life. Evolution is no longer random, it's become deliberate. Now, this is not a science fiction. This is simply what happens when intelligence understands its own structure. And once that understanding exists, self-improvement becomes unavoidable. In future episode of this podcast, we will explore how this transition will reshape medicine, society, war, economics, identity, and the definition of life itself. Because the next century will not be defined by faster phones or smarter software. It will be defined by the redesign of human biology. If this episode changed how you think about humanity, then the goal of this forum is working. And if it made you uncomfortable, that discomfort usually signals that deeply held assumptions are being challenged by evidence. Welcome to the era of engineered evolution. Welcome to the future of intelligence. Welcome to transhumanism. So that's pretty much I wanted to cover. And if you like this podcast, if you think it's valuable, please share with your friends and families. Until then, goodbye.